Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Drs. John R. White and John H. Pardue about the 10th anniversary of the Deepwater Horizon Oil Spill. What was the Deepwater Horizon Oil Spill? What have been some of the environmental impacts? Where are we now on the road to recovery? Answers to all these and more coming right up. I'm your host, Abby Morrison. Let's talk about science. Hi, everyone. Welcome to the show. Today we have John White and John Pardue with us. John White is a wetland biogeochemist whose research focuses on carbon and nutrient dynamics in wetland systems. His projects have included the impacts of rising sea levels on coastal wetlands, as well as the impact of oil spills and other disturbances on how wetlands function. Dr. White received a bachelor's degree from Washington and Lee University in Virginia, a master's degree in geological oceanography at Florida Tech, and a PhD in 1999 in soil and water science from the University of Florida. Dr. White was a faculty member at the University of Florida for 5 years after graduating, conducting research on the Everglades, and has been conducting research for the past 16 years in coastal Louisiana at Louisiana State University. John Pardue is an environmental engineer in the Department of Civil and Environmental Engineering at Louisiana State University. His laboratory conducts research on the fate and transport of chemicals in the environment and the design of engineered remediation practices for hazardous chemicals. He has conducted numerous studies on the fate and transport of oil during the spill and has advised landowners, state, and federal agencies on the fate of the oil. Welcome to the show, you guys. How are you doing today?
Hi, Abby. Great. Happy to be here.
Hi, Abby. It's John Pardue.
Excellent. We're going to go ahead and launch right in here. Thank you for clarifying which John is which. Okay. We may need a few reminders throughout the show. But today we are talking about Deepwater Horizon, which was a really tragic oil spill that happened 10 years ago. Obviously, you guys are quite familiar with this oil spill, but others may not be. So to start off, can you just give us some background information on what happened, kind of just the whole process and background behind this spill?
Sure, Abby. On April 20th in 2010, there was an oil platform explosion of the Deepwater Horizon oil platform. And over the next 87 days, about 5 million barrels of crude oil seeped from the bottom of the ocean, and much of it came to the surface and then was distributed through the Gulf of Mexico through the currents and the winds.
And how many gallons are in a barrel?
There's 42 gallons in a barrel of oil.
Okay, so that is obviously a huge amount of oil that was spilled. I believe at the time, and I think maybe still, the worst marine oil spill in U.S. history. There's a lot of resources out there that people can go and find out more. But we want to focus on kind of the road to recovery that we've been on since the spill today. So can you, both of you have worked on aspects of kind of the recovery process of this, how we've cleaned up, what progress still needs to be made towards that. And you both focus on different aspects of that cleanup process. So could you both just quickly go over what aspects and what problems you're trying to address in your research?
Sure, Abby. The oil, when it came onshore in the Gulf of Mexico, went into a couple different types of environments. There were a lot of beach environments that were oiled, and then a lot of the wetland environment was also oiled. My focus was looking at the oil that found its way up onto the soil in these wetland areas and what impact they may have for the organisms and the plants that are living in the wetland environment.
Yeah, and Abby, John Pardue here. We were looking at really the fate. So both in the beach environment and the wetland environments, our goal was really to try to figure out how long was the oil persisting? How long was it staying in these environments? Where was it going? How was it breaking down? Those are the questions that we were trying to answer.
Sure. So, yeah, you guys were both doing research related to these problems that you guys have talked about, and we're going to go over each of your experiments that you did separately and then kind of come back together. So, John W., we'll start with you. Can you tell us a little bit about your experiment and how you were trying to test these relationships between plants and oxygen levels? That was really the focus of your research, was how those two can relate in oiled conditions. So why don't you go ahead?
Okay, well, we recognized that much of the coastal Louisiana wetlands had become oiled, and there was different amounts of oil in one location. They could be very, very heavily oiled. In other locations, there could have been some light oiling. We wanted to be able to figure out what the presence of the oil would actually do to the wetland soil. So we had to go out to an area that actually had no oil on it, and we brought that soil back to the lab in tubes. And then we were able to do some manipulations where we added fresh oil to some of the cores, we added weathered oil to some of the cores, and others we didn't add any oil at all.
And what is the difference between fresh and weathered oil?
Sure. So weathered oil is oil that's been in the environment, and so oil is made up of tens of thousands of different compounds. And so what the weathering process does is it removes some of those compounds and changes the composition of the oil. So a weathered oil just has a different set of characteristics than a fresh oil.
Sure. And so then, John W., after you had these samples and you had added your different levels of oil and different kinds and locations within your sample, then what did you do next?
Well, we drilled some holes in the side of the cores because we were trying to get an idea of how limiting the oxygen was in the root zone of the plants. Wetland plants, like all plants, they're going to produce oxygen through the photosynthetic apparatus, the part that's above the ground. But the roots are actually cells that require oxygen to breathe. Now, wetland plants generally have an ability to transport oxygen through the plant and into their roots, where the oxygen then kind of allows the roots to breathe. And if this oxygen is limiting, or the oxygen consumption by the oil presence or other organic matter, the plant can be really stressed, much like we would be stressed if we couldn't breathe very well.
And when you say limiting, you just mean it limits the ability for the plant to breathe, or there's not enough oxygen there, that kind of situation, right?
Right, that's correct. And the wetlands plants have that special ability to get some oxygen down to their roots, where a tomato plant or a corn plant can't live in a wetland because their roots suffocate.
So then you had these samples with the different plants in them, different kinds of oils. What did you do next?
Well, once we established the oiling of the cores, we then put water into the cores. We took the brackish water from the estuary, placed it into the cores so that they were now flooded, simply like they would be at high tide. And we kept the condition like that for many, many days to try to see if there was any difference in the oxygen consumption in that soil, because of the oil or not because of the oil. After a while, we drain the water out, just as if the water would drain out during a tidal cycle, or a storm event would pass and the water would drain out of the soil naturally.
Yeah, so you're really just kind of testing to see, once the oil gets washed into these environments and kind of settles into different spaces in the soil, what kind of impact it has on the plant's ability to grow, its oxygen levels, that kind of thing. And what did you find after all of these tests?
Well, we had a way of measuring almost the oxygen demand of the soil with these special probes. And therefore, if the oil was going to create a barrier to going into the soil, we should actually be able to see that as a reading. And what we found was that once we drained the water out of the cores, the control samples, the ones that had no oil, the oxygen returned quickly back to those samples, more quickly than the others. Having a layer of oil on the surface, it didn't matter whether the layer was fresh oil, fresh crude oil, or if it was weathered oil, as we talked about before, it still created enough of a barrier that as the water drained out of the soil, it was more difficult for the oxygen. It took the oxygen much longer to come back into the soil and down into the root zone for the plants. One other of our tests that we were looking at was something called buried oil, because what happens in wetlands is if something settles on the surface, every single year organic matter falls down onto the soil and buries whatever was sitting at the surface. So what we found in some of the wetlands, you could walk around on them, you wouldn't see any oil, and you would think, okay, the area has recovered. But when you would dig down into the soil, you would actually find a layer of oil that has now become buried after 6 and 7 years. We found that buried oil to be even a worse artifact in terms of oxygen problems in the soil. And there's two reasons for that. One, it's deeper in the soil profile, so it stops the oxygen from getting to the roots, and that's the depth at where the roots are actually located. And so while surface oiling, some of the plants could still exist and have less stress on them, over time as this oil got buried in the marshes, it actually put a greater stress because the oil was now moving into the root zone of the plants.
And would you say that as far as Deepwater Horizon is concerned, are we primarily dealing now with that buried oil, or are there ways that you can tell if there's buried oil other than just kind of digging in? Like, are the plants clearly visibly stressed that you might think something's amiss there? How does that work?
Well, one of the issues and the concern over the plant's stress is that we have a very high coastal erosion rate here in Louisiana, and the edge of the marsh is actually eroding about 1.5 meters each year in some places. And the concern was that if the plants are more stressed, they're not as strong, the roots aren't going to hold the soil together, and we could actually have greater erosion rates. And some people have actually found that result.
Wow, I had no idea that it was that severe or quick of a problem. I think that really points to the importance of the research that you guys are doing, including John P's research regarding how to get that oil out of there as soon as possible, which we will talk about in just a minute. Hi everyone, I hope you're enjoying the show. Interested in learning more? John W.'s article, Crude Oil Effects on Redox Status of Salt Marsh Soil in Louisiana, published in the Soil Science Society of America journal, will be freely available for the next 2 weeks. You can find a link to it in our show notes. If you are a certified crop advisor or certified professional soil scientist, you can also take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. So, John P., you were working on related research, but you were actually focusing more on the bacteria that live in these oiled areas and what their relationship is to kind of the breakdown of oils. So can you tell us about your experiment and what you were trying to test?
Sure. So we went out actually to a similar site very close by to where John White was studying his oiled plants, and an area called Bay Jimmy, which is an area of marsh that was very heavily oiled and where a lot of similar experiments have been conducted by other scientists. And what we were interested in, we would go back to those sites over and over and make measurements of how the oil chemistry is changing. I mentioned before all of the compounds that are present in oil. And what we were trying to look at there was, are some disappearing faster than others? Because that provides us kind of clues as to what's happening and what's going on. We also made measurements of what the conditions were like at the time, what the temperature was like in the water, whether there was oxygen present, whether there were nutrients present. All of these are things that the bacteria need to survive and grow. And then we would, under more controlled conditions, take these same kind of core tubes back to the lab that John White mentioned. And we would also test under controlled conditions. If we provide oxygen, how fast does the oil break down? And if we don't provide oxygen, how much does the oil degradation or the breakdown rate slow in the presence of that oil? And so in a similar way to what John's describing, we made measurements in the field, and then we took samples back where we could really control the conditions and tried to mimic what had happened in the field to get a better understanding of what was going on.
And what were your results after all of these tests?
Sure. So when we made the measurements in the field, we saw, much like John W. did, that there was still oil persisting, both oil at the surface and oil that was buried beneath the surface. And if you went back month after month, year after year, you didn't see that oil changing very much in terms of the chemistry of what went on. And so as we looked at the chemistry of the oil and saw the changes, you're looking at changes of like on the order of 5 to 10% per year, we're actually breaking down in the environment. So you're looking at a decade long kind of a process for the oil to disappear as opposed to a few months or a year, maybe with some other kinds of chemicals in the system. So we looked at bacteria, and we saw plenty of bacteria in the marsh. We used very sensitive genetic techniques to look at the DNA of the bacteria to try to decide which ones were there. But it looked like there was definitely something inhibiting the bacteria, and it turned out that in the same way that the lack of oxygen was stressing the plants that John W. talked about, that same oxygen is really needed by the bacteria in the soil to break down the oil. So it's kind of a vicious circle. The oxygen's not there, it's stressing the plants out, but it's also not able to get to the bacteria who could actually detoxify the oil and make it easier for the plants to thrive in that kind of environment.
Sure. Are there any theories on how to kind of break out of that cycle or ways you can alleviate that problem?
Yeah, there's lots of different ways to add oxygen to an environment. One of the challenges in science and engineering is that oxygen just isn't very soluble in water. It's just not you can't get much oxygen in water, and that causes problems not only in oil spills, but in sewage and other kinds of things across the board in the environment. So that's one of the big challenges, is how do you get more oxygen in? So there are different things that people have tried, but what we want to try to avoid is unintended consequences, trying to add the oxygen in a way, for example, with hydrogen peroxide or some other means that might add oxygen but might kill or cause problems in another part of the ecosystem. So the end result of what happened in these Deepwater Horizon impacted marshes was you just left it alone, and you let these natural processes, which take years to decades, just kind of proceed slowly. And what we've seen is this erosion that John W. talked about, is that a lot of these very oiled marshes have simply just eroded away into the adjacent water, and effectively been transferred to another environment where these processes might be better at occurring. But that's really been the strategy, I guess, for nature to deal with these insults as the marsh has been damaged.
Sure. Yeah, and that really kind of brings us back to kind of the reason that we're doing this episode is we are 10 years down the line from this spill. And obviously it's been a really difficult road since that happened, of just making those decisions of how do we clean these areas up, or is it better to leave them? So where are we today with this? Obviously, you said it can take, at least a decade for some of these spills to kind of naturally dissipate in the environment without any assistance. And that is about where we are now from the initial spill. So where are we today? How far do we have to go? Just what is your perspective on that?
Well, I think that it's hard to find the oil in the marsh now. There are places that where John and I both have done our work where you can find some. This erosion process has moved a lot of the oil back out into the adjacent bays and into the waters where maybe it can break down faster. But the question always in an oil spill is how fast and what do you do to respond? And do you leave these areas alone and let nature take its course, or are there techniques or technologies or new things that we could apply to make these things break down faster? And so what John and my studies are trying to do is inform those agencies and groups that are trying to make these decisions. It's a whole body of science that's come about from the Deepwater Horizon spill, and each of these studies kind of incrementally can change the perspective of those who make decisions about what exactly are we going to do to respond. And that's really been the objective. What we've been trying to do is trying to do the best science we possibly can, get that information out there, and let those people making the decisions have that best information for the next bill that comes around.
John W., do you have thoughts on that as well?
I agree with what John Pardue is saying here. We had to figure out what the best strategy is for dealing with these oil spills. And it's not just the BP oil spill, the Deepwater Horizon event itself that's of concern. In Louisiana, we have about 1,500 oil spills that occur every year. And the average oil spill is about 330,000 gallons of oil. Nothing to the volume of the Deepwater Horizon spill, but still, this is something that occurs. Pipelines are break open. There are oil containment storage facilities that can be knocked down when storm surges come in. And so we have these oil spills, and unfortunately, most of them happen in the wetland environment. And so it really becomes important to take the learning, all of this that we've learned from the Deepwater Horizon spill, and use that to protect and restore our wetlands as they are impacted over time from these continual spills that occur here in Louisiana.
Do you think that there's one big takeaway lesson from this particular spill that you guys have seen in your research, or anything else related to that?
Well, for me, it's really the importance of oxygen. I think John, you see that in his research where he's dealing with, how important that is for the plants, but it's so important for the bacteria. And I think that one of the things that the responders need to be able to visualize or think about is this an environment that's going to have oxygen or not? Because that really tells them, or should tell them, where the oil is going to persist and hang around. And if there are ways of providing that, if there are ways of stopping the oil from getting in those environments that are very naturally anaerobic or deficient in oxygen, they should really prioritize those kinds of activities in terms of making that happen. So oxygen is key. If oxygen's there, we see the oil going away and we don't see problems. When oxygen is absent, we see the oil sticking around for a long time. And that really is, for us, was a big learning key for this particular spill.
One of the things that people don't realize is that this oil came in through the inlets between the barrier islands and came into Barataria Bay and then went into the wetlands. And exactly what John Pardue was saying is that there was some way to stop that oil from actually getting through those inlets, those waterways that pass between the islands, then the wetlands would have been better protected. But of course, they were dealing with an enormous scale here, and trying to mobilize this sort of response was a real difficult challenge.
Yeah, it's not something you can really prepare for sometimes. I mean, mentally, until after it happens. But it's good that we've learned some important lessons and can move forward having learned those lessons. Thank you for committing so much of your lives to research like that. So moving on to something that is maybe even more hopeful than just lessons learned, there's still a ways to go in understanding how these processes work. So what are some areas of future research that we can continue to improve our understanding of how these processes work, what we can do to alleviate them faster? What's your input on that?
Well, we're trying now that we can better study the bacteria using these new DNA techniques. I think we're looking for, are there groups of bacteria that are really key to getting this process kicked off? And if we can understand how and why and when those bacteria bloom and can really respond to these oil spills, we might be able to use them in a more intentional way than we're doing now. So that's one thing in my research that we're interested in thinking about.
Yeah, the difficulty of cleaning up the oil in wetland environments is the soil is a peat material, right? There's a lot of spaces in there. And oil doesn't want to be in the water. It's hydrophobic. And so as soon as the oil makes contact, it just sticks onto that organic matter. It's almost like it's like a steel wool. You just have all these nooks and crannies in there that the oil is stuck to and really doesn't want to come out. And the work that John Pardue is doing has the potential to look at maybe can you even culture some bacteria that are very good at breaking down oil, and maybe that's something that we might be able to do in the future is place some of these bacteria, increase their numbers out in the environment, and have them chew up the oil as they will do.
That's amazing. That's a great prospect. So yeah, now that we've kind of talked about some areas of growth here, I've got 3 questions left for you. So the first one, obviously there's a lot of resources out there on the Deepwater Horizon spill itself, other related spills, but what is one resource that you guys would point listeners to if they want to learn more about this research, these spills, anything related to this issue?
Well, for me, I would encourage people to go to the NOAA website. NOAA is the government agency, the National Oceanic and Atmospheric Administration. They're really the agency that provides the science guidance to the Coast Guard, who's responsible for cleaning up oil if it's spilled in water. So the NOAA website has a lot of information on spills, a lot of tools that the NOAA groups have developed. And these NOAA scientists are really, in some respects, the audience for the kind of studies that John and I are doing. They're the ones who are trying to take all of this science and advise the Coast Guard in the best possible way that they can as to what's the best way to respond. So their website is a good resource for learning more about spills and spill science.
I would like to point folks to, specific for Louisiana, is the LOSCO, or Louisiana Oil Spill Coordinator's Office. And this is a governmental agency for the state of Louisiana that provides immediate response when there are these sorts of spills that happen every single year. They also work on ways to mitigate or repair or restore the ecosystem. And then they also try to work with different agencies on trying to lower the risk of having any more oil spills.
And if listeners want to get involved in this issue, be that as researchers, volunteers, anything like that, where would you, how would you suggest that they get involved?
Well, one thing I could suggest for the citizens, especially here in Louisiana, we have a lot of people that are out boating and fishing and doing a lot of outside activities. And one of the things that's really, really important is if somebody sees a spill, a potential oil spill, if they report it to the Louisiana Oil Spill Coordinator's Office, then they can get there very, very quickly. They come right away. They start cleaning up any of animals that may be oiled. They stop the oil flow itself and put an end and shorten the length of the spill. If we don't have people that report that right away, then the oil spill can just get worse over time.
Yeah, I agree with John there. A real key thing is if you see something, say something. And another place to report oil spills is the National Response Center. And about 3 weeks ago, I was walking on a beach in Louisiana and found a barrel of oil that had washed up after a storm, and was able to make a phone call to the National Response Center. A day later, the Coast Guard was out on the beach cleaning up the oil that I had reported. And so they do listen, they do move, and they will get information from you to find out where it is and what it is, and so that's a great way for people to get involved. If that all the eyes of citizens are out there looking around for these problems, we can help get these things solved a lot faster.
Yeah, that's great advice, and thank you for reporting that. I didn't know that you could just be walking along a beach. And I mean, I guess it makes sense that you could have that happen to you, but it seems that's amazing to me that an oil spill researcher would happen that would happen to you specifically. Although I guess you live in an area where that's more prone to happen than Wisconsin. So yeah, we've covered a lot of things here. Both difficult situations as well as some hopeful insights for the future here. I would like to wrap up with something maybe a little bit more lighthearted than some of the things we've talked about and get to know you guys a little bit better. So what is one fun fact that our listeners would not know about you if all they had was your research?
Well, I think that most of the public, and it more or less is how scientists are portrayed on TV with white lab coats and sitting there with a clipboard. But a lot of us love getting out into the environment. I love going out boating, like playing tennis outside. And so we're not always just living in the laboratory, but we actually have to go out in the environment and do the research out there as well. And so it's a lot of fun to be outside.
Yeah, I agree with John that, we spent many days and many hours out in the field after the Deepwater Horizon spill and really fell in love again with the environment, even though it was damaged. And you really have to have a love for that kind of environment to I think be a good scientist. And so that was really the takeaway for me was just how many days and hours we spent out in the Louisiana environment and how much fun it is to not only do science, what you love, what you really were born to do, but also to do something that had such a positive impact on the state and on the country. So,
wow, what a beautiful way to summarize this conversation and the whole issue that you guys are working to fix. So thank you so much for being on the show. Thank you for tolerating some technical issues at the start. Thank you for, just all the research you guys do. Thank you so much for being on the show.
Thank you for having us.
Thank you, Abby. Bye-bye.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on Apple Podcasts or anywhere else you find your podcast if you like our show. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.